to introduce Dr. Michael Dietz. Mike is a professor at UConn. He teaches water quality management and green stormwater infrastructure. He's also a water resources extension educator and the director of the Connecticut Institute of Water Resources. So he's going to talk about our upcoming current issue. So for the 25-26 year, the current issue is going to be non-point source pollution. It starts at home. Without further ado, I would like to introduce Dr. Michael Dietz.
Thank you, Jane. Feel free to hold your applause until the end and see if I really deserve the applause, okay? So first of all, I just wanted to say a big thank you to all of you, because as I understand you're all teachers. I cannot think of another more deserving group of some appreciation, especially in these tough times, for the hard work that you do every single day. So my great sincere appreciation to all of you. I get to teach at the university level and I feel like I have it easy. I feel like you all have it a lot harder than I do. I don't have anybody telling me how to teach in my classroom or to teach to any state standards. And most importantly, I can swear in the classroom and nobody really cares. So again, I just wanted to tell you how much I appreciate what you do. So because of the weather today, I'm happy to shift things around a little bit and make this what you want, what you need out of it for your students and your teams for this year. So I have some stuff that I'll talk about. Please feel free to ask questions throughout the beginning part of this. And then I have a couple of exercises. So you didn't think you were going to get away with having to do nothing in here today, did you? I'm a teacher too. I get to make you do some work in here as well. So I'll do a little bit of an exercise, and then we have some flexibility after that with what we do. I have some more stuff that I can talk about, which I'll get into then, or we can take this whichever way you'd like to go, and I'm happy to do whatever. All right, so let's get things moving here. Okay, so I'm going to start out with the background information here. Many of you probably know this, especially if you're science teachers, but I just wanted to get us all on the same page for the stuff we're going to talk about what the different types of non-point pollution are. I'm going to go into a little bit of an exercise as to how you can assess your particular school for retrofit opportunities to reduce non-point source pollution. This is something that I do with one of our classes on campus. The outside activity, we can scratch that off for today. And plenty of time for questions. We'll keep that in. All right, so starting out with the water cycle. Again, this is basic stuff for many of you, but I just need to point out here the water cycle obviously is going on around us all the time right now. I didn't think about the water cycle when I walked out of the door this morning, but this is our global cycle that's happening at all times. This point right here, where the precipitation hits the landscape, is the one where we as humans have had a dramatic impact on the water cycle. So that's what we're going to be talking about for the urban non-point source pollution. There's a lot of other stuff that's been going on globally with the water cycle because of the, let's call it, excess energy that is in our climate system now. So as a state-funded person with federal funding at our institution, there are certain words that I cannot use anymore. But if any of you said them, we could acknowledge that, but whatever, I'll leave that up to you. The bottom line is there are big changes that are already happening in our atmosphere. This is not looking forward and predicting anything. I can turn around and point backwards and show you how our precipitation totals have been increasing dramatically. And if you've lived here in this state for a long time, you know this. You know we're getting more intense storms in shorter periods of time. So this is real stuff that's already happening, and this is just exacerbating humans' activities on the landscape. So another basic concept, again, I apologize if it's something you teach, but the concept of a watershed. So how many people live in a watershed? Most of you, okay. The few that you did not, maybe you're English teachers or something and you don't think about watersheds too much, that's okay. But maybe you just didn't see a sign like this that's a public drinking water supply watershed near your house. This is what most people think of when we talk about watersheds, a public drinking water supply. But in fact, we all live in a watershed. So a watershed is just an area of land that drains to a single point on a stream. So we could find a very small stream that's out here, and the area of land that drains to that might be an acre or two. I could go to this parking lot. When I came in, there was a catch basin out there where water was draining into it. I could delineate the area of that parking lot, and that's a watershed also. We could also look at the watershed of the Connecticut River, where it dumps into the Sound. That goes all the way up to Canada, thousands of square miles. So that's the point. It just depends on where you put that point on the stream. A couple of resources for you, and I'm going to highlight these again at the end. These are things you can use with your students. If you haven't seen this already, it's a really neat tool. This is something that EPA has created. Hopefully this tool gets maintained given the 55% cut in EPA that's been proposed. Again, I'm just talking about facts here, not politics. So this tool, as of today, still exists. It allows you to put your address in, and it will pull up the local watershed where you are. It shows any kind of water quality data that's available for that is provided by the state, and gives you some information about what the causes of those problems might be. So it's a nice exercise for students to look at to see what's going on nearby. If you wanted to delineate an actual watershed of a water body, back in the old days when we were in grad school, that was done by hand with a topographic map. Maybe if you were lucky, you had a planimeter to help you measure the area after you did the delineation. But fortunately, just like everything these days, there's an online tool that helps you to do that. So the USGS, again, having major funding cuts right now. Hopefully they will still continue to maintain this site, although they are getting cut for some of their other monitoring efforts that are going on right now. So this particular site is quite useful. It's called StreamStats. So also you can put in your address and zoom into a site. This allows you to drop a point anywhere along a water body. And the software will then delineate the watershed for you, the area of land that drains to that point. It doesn't tell you anything else about the quality of those waters in there. This is more the exercise of the watershed itself. It gives you a little more control over where you're putting that point. The other cool thing about the data that it gives you, if you or your students are doing any GIS work, that you can export that watershed as a shapefile and bring it into ArcGIS Online or other tools so you can manipulate it and do other stuff with it. So really, really useful tool. So before we talk about non-point source pollution, it probably would help to define what point source pollution is so we can say what we're not going to talk about today. So point source pollution is something that comes from an identifiable place. It's coming out of a pipe that looks bad, smells bad, has a chemical smell. It's probably a point source of some sort of pollutant. So this used to be discharges from factories, discharges from municipalities, big cities, raw sewage, all of the above. So until the 1970s, this was primarily the cause of water pollution in this country. So at that time, these were common sites. So this is the Cuyahoga River in Ohio, one of the many times that it caught fire. I know your teachers, you probably are aware of the fact that water should not be catching fire. So obviously it's all that stuff that was floating on the top, oils, chemicals, other discharges. And our waters were a disaster in this country at that time, as was our air. But because of PL 92-500, anybody know what that is? Clean Water Acts, thank you. So that happened in 1972, the Water Pollution Control Amendments of 1972. It happens to be a very good year. It's the year I was born. Okay, see? Unfortunately, as you can see, I have more hair in the picture there than I do now, but this is how it goes. The fact of the matter is, in my lifetime, there have been dramatic improvements in the quality of the waters in our country, in this state in particular, and in our entire country. We had rivers that were catching on fire at that point in time, and people had had enough of it. The grassroots effort that happened across this country really brought about tremendous change in the quality of our waters and our air. And I don't need to be telling you this because you're all here today. You understand the importance of these regulations, this stuff. People, the municipalities, the businesses were not doing this stuff on their own. This regulation was needed to bring about this change. So some of these things are trying to be rolled back at this point, and there's tremendous danger in that. So bottom line, we are in much better shape than we were now, but what we're faced with are some of these non-point sources of pollution, which can be more challenging to identify and control. So the two typical non-point source pollutants are agricultural runoff and urban runoff. So I'll give you a little bit of information about the ag side, but because Connecticut has so much more urbanized area than ag lands, it's about 2 to 3 times more really. We'll focus mostly on the urban stuff today, but I'll at least have the information on the ag for you here. So let's just start with that. These are farms in the United States. So 1 dot equals 200 farms. So as you can see, lots of dots on this map, especially in the breadbasket of our country, which also happens to be the watershed of the Mississippi River, drains out into the Gulf of Mexico. Yes, I said it. So agriculture happens to be the top source of pollution in our country in US waters. So every 2 years, our states need to submit water quality reports for each of the states to EPA. So EPA then combines all that data, and I should have put that. I'll get that link for you after if you don't know about that. But there's a place to look at the individual reports for each state and to look at the nationalized data. But across the board, right now, the largest source of pollution in our nation's waters is agriculture across the country. So this is because of excess fertilizers, pesticides, animal waste, and because of that very large watershed of the Mississippi River that drains into the Gulf of Mexico. All that stuff causes a lot of problems downstream and has resulted in a dead zone in the Gulf of Mexico of varying sizes each year, but it's a result of all that agricultural activity. I'm not trying to tell you that farmers are bad. Most farmers are trying to do the right thing. They're trying to make a living, trying to feed their family and provide food for this country. It just happens to be that some of the practices result in, if they're not managed well, they result in this type of thing happening. So these are some of the things that we try to get farmers to avoid. And I know that we have some colleagues that have, or folks in here have worked with other colleagues in NRCS and other organizations. So we try to keep animals out of the waterway. That's one easy thing to do, keep the grazing out. It's also more beneficial for the ecosystem. The large ag operations are really the big problems when it comes to like acute sources of pollution for local waters. So down in North Carolina, the large hog facilities where you have these large lagoons of hog waste, one of the big hurricanes that came through there a couple of years ago, this was a huge issue when those lagoons released and got into the local rivers. So that type of thing is a real problem where you've got large numbers of animals confined in one area. It compacts the soil. That's another topic for outside today. When it does rain on that, the animal waste and everything else goes off that site as well. Also, improper fertilizer and pesticide applications, if they're timing this. So if someone put fertilizer down yesterday, there's a high probability that it's going to be running off the soil today. So trying to time that stuff when it's not going to be lost and when the crops can most readily use it. And that same thing applies for residential lawns. That's not just a big farm issue. So that's it for the ag. Any questions on that before we move into the urban stuff? Okay. All right, so the big driver here, what's mainly driving these issues with urban runoff and urban non-point source pollution are impervious surfaces. So if we talk about a watershed, for example, that has forest cover with no development in it. So a pristine watershed that looks something like this, a stream that drains it, we would expect it to look something like this. So we've got lots of good forest cover over that stream, keeping the temperature low. This is good for species that like that cool water habitat, like native brook trout, other things. The vegetation on those banks helps to hold it intact, so when there are natural floods, things don't erode as easily. We have a nice pool and riffle structure in there. If anybody likes to fish for trout, you know this is good habitat. Perhaps there may be some trout in this room today, depending on how much rain we get. As we develop a little more on the landscape, we tend to see streams that start to have some modifications to them now. So we have parking lots that may be draining directly into that stream. We've had to armor the banks of that stream. Why do we have to armor the banks of that stream?
Protect the infrastructure.
Protect the infrastructure. because of erosion. We got too much water now that's coming off of some of the impervious areas that are in that watershed. And we've had to armor those banks to keep it from eroding. We no longer have the good tree cover over that stream, so the temperatures tend to be higher. And we've straightened them and made it less great habitat for aquatic life. If we go a little further along the continuum, this is West Hartford. I drove through here this morning. I drove right by the Trout Brook Drive exit. If anybody's been to West Hartford, great restaurants, by the way. I do like to go down there for the restaurants. But I would not be going to Trout Brook to find trout, okay? When we've had so many modifications now to that watershed, we've got so much excess water going in, they've had to put cement on the banks now to keep it from eroding. Not good habitat for aquatic life. And then at the extreme end of the spectrum here, we have Hartford. So if you're in the back, it's hard to see. But this is Bushnell Park. So here's the Soldiers and Sailors Arch. If anybody's run the Hartford Marathon, you run under that. There you go. So did you notice, the one you in the back, did you notice the stream under there when you ran over the arch? No, that's right. Well, you were probably dying when you were running over the finish line, so that's fine. But that stream was, this postcard is dated 1905. That stream disappeared in the 1950s and was put underground into a large tunnel. So that's the Park River. Because of major flooding that happened and all the excess development that drains into that river, this was completely buried under the city, so you don't see it at all anymore. So this is quite common in our heavily urbanized areas and really destructive to any kind of ecological habitat in that system. So is it really that big of a deal? So I come from a family that no one went to college. I was the first person actually to go to college in my family. My uncle and my father had a construction business. So to this day, my uncle just retired from that business. And let's just say that our holiday dinners tend to get a little lively given what I do. They know that I do something with water. They're really not sure what, but our discussions tend to get a little lively. So he always says, but it's just rain. What's the big deal? A little rain, extra running off the parking lot. What does anybody care about that? So let's just do a quick example here of where we're sitting. So here's the canopy where we're sitting right now. The rest of that building is, as you can see it. This is just about 12,000 square feet of impervious cover on this site. So if we get 1 inch of rain, which is probably what's going to happen today, 1 inch or more, would they say 1 to 2? So 7,400 gallons of water are going to run off the roof of this building. Where does it go? I can look out the window right over here. I see one gutter downspout that drains onto the lawn. That's a good sign. I did see some others that are into pipes. When it goes into a pipe, most of the time, it goes out to the nearest waterway. And here, what I could see on the image, the nearest waterway is the pond, right down there. So this water makes its way to the pond. So this building is directly connected to that water body. How about in an average year? How much precipitation do we get in an average year? Come on, you hate it when your students don't answer your questions too. 40 inches, not bad. So it's about 48. 48 inches, 356,000 gallons of water come off of this one site. This is one tiny building. Go to our nearest big city, or if you have the stomach for it, go to New York City. I really can't handle it myself. But now imagine the trillions of gallons of water that would go off of New York City in just this one event that we're having today. That water needs to be moved away from where people are so people don't die. It needs to protect the infrastructure, and it needs to be sent out somewhere. And those trillions of gallons of water have a tremendous impact on those receiving waters. So this is a big deal. So because of our development on the landscape and the changes that we've made, this has dramatically affected the hydrologic cycle, increased the quantity of runoff and the rate of runoff. And then the stormwater and combined sewer overflows also degrade water quality. So I'll talk about that in a second. I guess the one thing I'll just say with the stormwater, everything that goes on in that watershed, if someone is misapplying fertilizer, as we talked about, it gets spread on, a little bit gets spread on the sidewalk, on the road. This happens all the time. I see it happening everywhere. The next time it rains, that stuff goes right out into the nearest stream. And that has major consequences downstream for the aquatic life. So I'll get to the combined sewer thing in just a second. We're out of the holidays, but one of my favorite holiday movies is Christmas Vacation. And there is some wisdom in there about what not to dump in your storm drain. So Cousin Eddie gives us some advice on what not to do, okay? All right. So a combined sewer overflow, this basically happens in our older cities. In the eastern part of our country, the majority of the cities had a combined sewer system where the stormwater was directed into the sewer lines on purpose in the 1800s when they were building these cities. Why did they do that? Because we didn't have any treatment for the sewage. It just went to the nearest river. So it was actually beneficial to have the stormwater come in and move that sewage through and keep that system flowing quickly. So they did that on purpose. Once sewage treatment started to be employed in the 1940s and 50s, it started to become a problem with the extra water that was going into those plants. So this is the way it works if you're not familiar with this. Right now, the sewage now goes to a water treatment facility where they take out most of the solids, the nutrients get cycled, and that cleaned water gets discharged or gets sanitized and then discharged into the nearest water. So they've addressed most of the water quality concerns for the sewage. When we get a little bit of rain, the facility can handle that and can process that water too. The problem happens when we get a lot of rain. And that number just depends on where you are. So in Hartford, there were parts of the city that if they got more than a half an inch of rain, people had sewage and stormwater backing up in their basement. So Hartford is drilling giant tunnels under the city now to temporarily store this mixture. So in a big storm, they have these points built into the system so that because they know the facility can't handle it, it discharges this tasty elixir of raw sewage and stormwater directly into the water body. So in a big storm, this is happening all around us. It happens north of us on the Connecticut River, Chicopee, Massachusetts, Springfield. There are places where they have to notify the Department of Energy and Environmental Protection about this when these happen. So I don't know what the I guess DEP, but Connecticut has a website where you can track this. The DEP has that. So Hartford, New Haven, Bridgeport, all of our big cities, if they discharge a CSO, they have to say how many gallons it was and for how long that event happened. So if you've tried to go to the beach with your kids in the summer on your much earned vacation time, if you're taking a real break, and the beach was closed because there was a big storm the day before, this is why. The Department of Public Health has to test those swimming areas, and if there's too much bacteria, they shut it down. So this is a big problem, and EPA is, most of our big cities are under abatement from EPA to address this issue. All right, so any questions so far? Again, please don't hesitate to ask. So there is a little bit of hope here. So in the 1990s, because of development concerns in the Chesapeake Bay, or in the watershed of the Chesapeake Bay, I should say, there was a lot of development going on. There were farms there as well. And they had major issues with water quality in the bay, but they wanted to improve the water quality because it was degrading something that was very special to them and had great economic value to them. But they didn't want to shut down development completely. So they instituted something called low impact development that was basically a way to still allow development, but to do it in such a way that it reduced the impacts on the local receiving water. So it reduced non-point source pollution. So the main takeaway with this is that they preserved, or the goal was to preserve the pre-development hydrology of the site. So how that little area, we'll call it a watershed, functioned before there were homes on it. So in that undeveloped condition, we try to replicate that. And I didn't say this at the beginning, but I know they're recording the presentation, but I'm also happy to share this whole slide deck with anybody if that's useful. Some of the stuff later on, if we don't get to it, I'll just show you what's there, and I'm happy to share it with you, to have you use it. So actually, I'm gonna go back to this for just a second. So there's a lot that goes on before they even build on a site. There's a lot of planning that's a little bit different than traditional development planning. Then when we get into how to manage some of that runoff, we get to talk about some of the fun practices like rain gardens, permeable pavements, and green roofs. So rain gardens are one of the tools that are in this LID toolbox. These are also called GSI now, or Green Stormwater Infrastructure. You'll hear that term. So these are built features that direct stormwater into the ground, replicating that natural hydrologic function. So the plants, the soils, and the microbes help to cycle those pollutants and prevent them from leaving the site. They also provide ecosystem benefits. So we could just infiltrate water in some buried crushed stone under the ground, and that would accomplish the same thing. But it would not have the ecosystem benefits that the rain gardens do. And they also would not have the aesthetic benefits. So these also provide something nice to look at. So here's an example of a small one up at UConn. At the university, at the main campus, we have over 70 individual GSI practices installed at this point. This started back in 2004, and we continue to put them in with any new redevelopment on site. So as you can see, pretty nice to look at, nice pollinator habitat. This is a disconnection of a stormwater pipe, directing that water out into the rain garden. So some of the larger systems that we have at UConn now, they're trying to have them look more like a natural stream system. For a while, we were doing some more engineering hardscape look, but we've tried to get into more of this organic form now that really look like a natural stream system, and they're spectacular. So this is one of the new student buildings, the Science 1 building. They have some nice signage there so students and visitors can learn about what it is. At the UConn Dairy Bar, I had a group of students a year ago. It was a year and a half ago, so it was the fall semester of 2023. And they were all excited about rain gardens, and they had a project that they had to do for one of their classes. So they came to me and said, can we put in a rain garden? And I said, it's wonderful, great idea. And they were expecting that this garden was going to go in about a week, but it took a year. Well, it took 2 semesters, which for students is like a year. And we had to step them through the whole procedure at the campus to get all the approvals and this and that. And they actually applied for some funding through the university to get money for plants, and they successfully got that funding. So I basically just helped out and facilitated some of the hardscape work that needed to be done, but this was really a student-driven project. So this was a site, and I'm going to use this as an example in just a second to show you here. So this was an existing building that had some downspouts and a great opportunity for a retrofit, because if you can't see it there, that's just a yard drain. So prior to the students being interested in this project, these drain pipes tied into that drain system and went out directly to a local brook, which is on the impaired waters list from DEEP. And that was just the way it was. I had seen this site before and thought that it was a really nice, easy retrofit opportunity. So that's where I steered the students here. So here they are. We took the grass out, brought in some soil, raised up that yard drain, and they had organized a nice planting day. They did the whole planting list themselves. There's the finished product. The drain is now elevated so that garden will fill up and encourage water to infiltrate before it would overflow in a big storm. And here it is last summer. That purple coneflower I was there, happened to see some monarch butterflies there. There's some of the larvae later on in the summer. And later in the fall, here are the asters blooming. So the students gave some thought to the bloom throughout the season. So they did a really nice job with this, and it's been a very successful project. Permeable pavements are also an option. So there are alternatives to the traditional concrete and asphalt. These allow water to pass through the surface and get into the groundwater underneath, again, replicating that pre-development hydrology. We've got a lot of examples up on the UConn campus, but there are other places in Washington, D.C., New York City, Philadelphia is doing a lot of this. This is not just a Connecticut thing by any means. Green roofs are also a new tool. Well, not new. These have been around for thousands of years, really. But the newer style green roofs are a thinner media that's lightweight. They grow these smaller plants that are called sedums. Many of you probably know what they are. They're a succulent type plant, very hardy, can handle those harsh conditions up on a roof. So these have water benefits that they will capture on an annual basis, about 50% of the water that falls on them, and send it back up to the atmosphere. The rest will just overflow, but still 50% is pretty good if you're looking at a big city that has a lot of rooftops. Chicago is the nation's leader with millions of square feet of these. New York City's catching up. But these are all from the UConn campus. We have quite a few up there.